Welcome to our quick tips guide on the hardy-weinberg equilibrium. This is an essential concept in population genetics. The hardy-weinberg principle provides a mathematical baseline for a population that is not evolving. Specifically, it describes how allele and genotype frequencies remain constant from generation to generation in a non-evolving population. To master hardy-weinberg, you need to understand the two core equations. The first is the allele frequency equation, P plus Q equals 1. Here, P represents the frequency of the dominant allele, and Q is the frequency of the recessive allele. The second is the genotype frequency equation, P squared plus 2PQ plus Q squared equals 1. This represents the frequencies of homozygous dominant, heterozygous, and homozygous recessive genotypes, respectively. For the hardy-weinberg principle to hold true, a population must meet 5 specific conditions or assumptions. First, there must be no new mutations, no gene flow or migration, and no natural selection favoring certain traits. Second, mating must be random, meaning individuals do not select mates based on genotype. Third, the population must be extremely large to prevent genetic drift, which is random changes in allele frequencies. Now, let's talk about the practical steps for solving hardy-weinberg problems. The best tip is to always start with Q squared, the frequency of the homozygous recessive genotype, which corresponds to the observed recessive phenotype. Once you have Q squared, take the square root of that value to find Q, the frequency of the recessive allele. Next, use the allele frequency equation P equals 1 minus Q to calculate P, the frequency of the dominant allele. With both P and Q, you can now easily calculate the remaining genotype frequencies, P squared for homozygous dominant and 2PQ for heterozygous individuals. Understanding hardy-weinberg is more than just solving equations. It's a fundamental concept in evolutionary biology. The principle serves as a null hypothesis, providing a benchmark to detect if a population is indeed undergoing evolutionary change due to factors like selection or genetic drift. In conclusion, the hardy-weinberg principle is a powerful tool for population genetics. Remember the 2 key equations and the 5 main assumptions, and use the step-by-step method starting with Q squared for problem-solving success. Good luck!